Good morning. In the lesson today, we're going to begin to look at some straight line concepts. And the first one here is slope. So a slope can be positive if it is rising to the right. A straight line that is falling as you move left to the right is said to have a negative slope. A horizontal line will have no rise and therefore its slope is 0, while a vertical line with a run equal to 0 is going to have a slope that's undefined. So we can use the following to calculate slope. It is the rise over run, which means it's also the change in y over the change in x. This makes it y2 minus y1 over x2 minus x1. So we begin by performing a couple of slope calculations in this first question. Determine the slope of the line that passes through the given points. So let's go ahead and try A here. And I'm going to be using this formula here. And so I'm going to make sure that I use x1, y1 as this first point, and then x2, y2 as this second point. We would get the same slope if I reversed these things. The slope calculation would come out the same. Okay, so here I go. I'm going to do y2 minus y1. So that would be negative 4 minus 4. And in the denominator, x2 minus x1, negative 7 minus a negative 3. And so in the numerator now, I will have negative 8. And the denominator is negative 7 plus 3, or negative 4. And this means the overall slope is positive 2. And that's all there is to it. So we'll do one more together. Here's a second example. And again, I'll just label my points like this and then use our formula. So y2 minus y1 will be 3.4 minus 4.2. And under it, x2 minus x1, 1.2 minus a negative 2.8. This numerator now is equal to negative 0.8. And under it, we have 1.2 plus 2.8, which is 4. So the slope is obtained here by dividing, and you'll get negative 0.2. And sometimes it's important to express your slope as a fraction so that you can identify the rise versus the run. So you may know that 0.2 is a fifth. So this is equal to negative 1/5. And if you didn't know that 0.2 was 1/5, you can think of it like this. It's 2/10. That's how you would say this number, 2/10. And 2 over 10 can be reduced, and it is 1/5. So the slope for part B is negative 1/5. So that means, you know, the rise is negative 1 and the run is positive 5. Okay, we're going to try this exercise now. We're going to sketch the line with the given slope and y-intercept. So part A, we have a slope of 2/3 and a y-intercept of negative 1. The y-intercept is the point where the line crosses the y-axis, and it will always have a corresponding x value of 0. Okay, so I'm going to try this first one here, part A. So I'm going to start just by drawing my axes here. All right, like that. Making sure I identified the X and Y axes. All right, and then I'm going to start at the point, the y-intercept, and it's the point 0, -1. So 0, -1 is right here on my graph. Okay, and now all I need to do to sketch the line is to find one other point on the graph. And I do this by using the slope. You see, we know here that the change in y is the numerator, so the change in y is +2. So what does that mean? That means up 2. The change in x is also positive. It's +3. So what does that mean? It means 3 to the right. So from this point, I need to go 3 to the right and 2 up. 3 to the right and 2 up. Right there is the second point on the line. Okay? And what are its coordinates? Well, the coordinates are identified by starting at the origin. So this point is 3, 1. Like that. And then I can just connect the 2 points, all right, to draw the straight line. And of course, that's 2 points, but there are an infinite number of points on every straight line. We use the slope just to find 1 point in addition to that y-intercept. Okay, you can see here you can make a little triangle. If this is helpful to you, then I encourage you to do this. You can make a little triangle like this, and then you see this side here is the change in y, which is equal to 2. See, 2. And this side here is the change in x, or the run, which is equal to 3. Okay, let's try this one. So part B. Once again, I'm going to start at the y-intercept and then apply the slope to get a second point on the line. Okay, so y and x beginning at the point 0, -2. That point is right here on my graph. 2 units below the origin. Okay, now the slope is -4. So from this, I should be able to obtain information about the rise and also the run. So I need to remember that -4 is the same as -4/1. So now that means the rise is -4 and the run is +1. So I can find a second point on this line if I go 1 to the right, +1 for x, so 1 to the right, and 4 down, okay, since the rise is negative. So 1 to the right and 4 down puts the second point right here. What are its coordinates? Always the x value first, so the coordinates are 1 and then -1, 2, 3, 4, 5, 6. 1 and -6, like this. And simply connect them. Okay, I kind of missed the dot, sorry, but you get the idea. The straight line should have gone right through the middle of both of those dots. Okay? Okay, let's move on to our next concept here, which is the equation of a straight line. And the equation of a straight line is given by y equals mx plus b. M is the slope of the line, and b is the y-intercept. Okay, so specifically, In the previous problem, this is the b value right here, -1. You see, -1 is where the line crosses the y-axis. So b is -1. And what about in this problem? The line crosses the y-axis at -2. So the b value is -2. You see it here as well. Okay, so let's try this problem. We're asked to determine the slope and the y-intercept and then to also sketch the line. So in order to do this, we have to ensure we put the straight line into this form. The relevant part here is that y is isolated. So we'll move this equation into this form now. So the first thing to do is to isolate -5y. And this is done by subtracting 4x, like this. This is the same as saying that 5y is 4x plus 10 if you simply multiply all terms by -1. And finally, to isolate y, all you have to do is divide by 5. So the whole right side is divided by 5. And now, since I want to distinguish m and b here, I'm going to split this as required about the plus sign. So what will the coefficient of x be? It will be 4/5. Plus, and what will that constant be? 10/5, which is 2. And now we can directly compare these equations and state that the m value is 4/5 and the b value right here is +2. Once that's done, we're going to be sketching this. So remember that the y-intercept will always be of this form, 0b. So this will be the starting point on our graph, and then we'll apply the slope to it. Okay, so let's try that sketch now. So I'm going to locate the point 0,2 and then apply a rise of 4 and a run of 5. Okay, so I've already pre-sketched the axes. So again, we're starting at the point 0,2. That's right here on my graph. And from there, remember, we want the rise to be 4 and the run to be 5. So what does that mean? That means 5 to the right, 4 up. So from this point, 1, 2, 3, 4, 5 to the right and 4 up. 1, 2, 3, 4. Right there. And connect the dots. That's the straight line. Let's identify the coordinates of this second point. So from the origin, 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, 6. The coordinates of the point are 5, 6. Okay, just like that. And don't forget, if you like, you can always make your triangle. This is a positive slope. The change in y here is the difference between 6 and 2. So it's 4, while the change in x is the difference between 5 and 0. Like that. Okay, let's try the next one. So here we have the equation y is -4x. We already have y isolated, so we can go to the point at which we compare the equations. Comparing them, you should find that the slope is -4. There is no constant in the right side here, no constant term. That means b is 0. the y-intercept is always of the form 0b, and so in this case, it is 0, 0. And this is the important point called the origin. Okay, so we're going to start from the origin, which happens to be both the x-intercept and the y-intercept. And then we're going to apply the slope of -4. Remember, this means -4 over 1. Okay, so let's do that. So this is the sketch to accompany y equals -4x right here. So we start from the origin, since b was equal to 0. And look, that's called an x-intercept and a y-intercept. And now we need to apply that slope. So it was, remember, -4 over 1. So what does this mean? 1 to the right, 4 down. So from this point, 1 to the right, and then 1, 2, 3, 4 down, right there. So this point is 0, 0. This one here is 1, -4. Like that. And now we have 2 points on the line as required, and we can connect them like this. Okay, great. Let's go on to look at problem C right here. So first, check. Do we have the right form? Well, y is not completely isolated. To isolate y here, we have to divide both sides of the equation by -2. So 7 divided by -2 is -3.5. So now we have our equation, y equals -3.5. Now we compare it with y equals mx plus b to identify m and b. Now remember, m is the coefficient of x. The term containing x is absent. This means its coefficient is 0. 0 times x would remove that term from the right side. And so then, what is the b value? Well, the b value is the constant. So this means b is -3.5. Okay, so writing the equation this way, y equals -3.5, it's the same as this. Y equals 0x minus 3.5. With m being 0 and b equal -3.5. So now we have an ordered pair, 0, comma, -3.5. So this is the point at which we start. That's our y-intercept. And from that point, we're supposed to apply a slope in order to get a second point on the line. So let's try that. Okay, so here we are. -0, -3.5. 1, 2, 3.5, I'm going to say is right there. Okay, so that's the point, 0, -3.5. Right there. Now, I'm supposed to apply a slope of 0. Okay, so the rise is 0. Now, what is the run? Well, 0 can be thought of as 0 over 1 as well. So we could use that to find a second point on the line. Okay, so if you want, you can think of this also as 0 over 1, in which case we would have the rise is 0 and the run is 1. So from this point, what would we do? 1 to the right and neither up nor down. So from this point, simply move 1 to the right. And that does give you a second point on the line. And if this point here was 0 and -3.5, this one right here would be 1 and negative 3.5. Okay, I think you probably realize that what we're going to be drawing is a horizontal line. Okay, the horizontal line is the line with slope equal to 0. And there are, of course, an infinite number of points on this line. This one here, for example, negative 2 and negative 3.5. But the point 100 comma negative 3.5 would also be on this line. The point negative 8 comma negative 3.5 would also be on this line. Okay, but again, we're going to be drawing the lines just using 2 points. And then we extend the lines beyond the 2 points. See how we've extended them in each case? Just to show that the line is never ending. Okay, so that was example C, the line with a slope of 0. So that's a horizontal line. Okay, one more example and then we'll take a break. So here we go. This does not look anything like this form, so we need to isolate y. As soon as you see these decimals, you might want to begin by multiplying all of these terms by 10. And that might be a nice start for us here. Okay, now we're going to isolate y. So first we're going to move this term to the other side. So it is going to be negative 15x plus 30, like that. And then I would just need to be dividing all of the terms by negative 24. Or if you like, you can make this positive 24 first, as long as you multiply all 3 terms by negative 1 like this. And now, yes, we're going to be dividing by 24. So here's what we get. We get 15 over 24x minus 30 over 24. The slope should remain as a fraction because remember, we need to have information about rise and run, but we are going to reduce this. Okay, so here these numbers are divisible by 3. So that's going to be 5 over 8x. Okay, this number, however, the y-intercept, remember it's fine as a decimal. So you might prefer to go to a decimal here. So 30 divided by 24 is 1.25. So now we can compare it. It's in perfect form for comparison. And what do we find? We find that the slope is 5 over 8. The value of b is negative 1.25. Thus, the y-intercept is the point 0, comma, negative 1.25. So here's where I'm going to start in the graph, and here is the slope I will apply. Okay, so let me find this point on the graph for you, and then we will apply the slope to get our second point. Okay, so it was 0, negative 1.25. Okay, so negative 1 is here, negative 1.25 just below it. So I'm going to say right there, okay? Because remember, this would be negative 2. So that's the point 0, negative 1.25. Very good. And now from there, what do? We are supposed to apply the slope. The numerator was 5, so the change in y will be 5, while the denominator was 8, so the change in x will be 8. So we're going to go 8 to the right and 5 up. So 8 to the right, 1, 2, 3, 4, 5, 6, 7, 8, and then 5 up from negative 1.25. Okay, so what you're doing is you're adding 5 to negative 1.25. So that's going to get you to 3.75. So 1, 2, 3.75 right there. Okay? And the coordinates of this point are, so from the origin, 8 and positive 3.75, like that. Okay, connect them. And then you're all set. And again, just to show you one last time, if you want to be doing your triangle thing. Oopsie. Your triangle thing like this, then you would say, okay, change in y from negative 1.25 up to 3.75. That's a change in y equal to positive 5. And here, the change in x is equal to 8. Okay, I probably should show you, just before we end, I should show you the triangle thing on a question with a negative slope, because the ones I've done so far have all had a positive slope. So go back to B for one moment. These are the 2 points. So this would be the triangle here. Okay, so we're always going to have a positive run in these examples. So the run here, right here, that's your delta x equal to 1. Okay, and here is your rise. Change in y is equal to negative 4. Okay, because the y value was 0 and now it's at negative 4, right? 0, negative 4. So the rise is negative 4, the run is positive 1. The line, see the line, is falling as you move from left to right. It's falling. Okay, so it's going to have a negative rise. In the way that we've done all of our examples today, our run will always be positive. It's just the rise that will be positive or negative. Okay, that's great for our first video of the unit. Please take some time to try the recommended problems as well. Have a good day.